Have you ever wondered what happens at the rear of a massive aircraft carrier often called a city at sea? While this floating metropolis houses thousands of crew members, it's at the rear, where the most critical and dangerous operations take place. Planes traveling at over 150 knots are brought to a halt in mere seconds, and every movement is a precise balance of cutting-edge technology and teamwork. What makes this part of the ship so vital, and how do hundreds of crew members ensure smooth operations day and night? The angled flight deck stretching across the rear section distinguishes carriers from any other naval vessel. This seemingly simple architectural feature enables continuous flight operations with the rear deck positioned approximately 10 degrees off the ship's centerline. Modern carriers like the USS Gerald R demonstrate how this design maximizes operational efficiency, allowing simultaneous launch and recovery operations while maintaining a constant flow of aircraft. The rear section contains multiple specialized zones, each serving distinct purposes. The primary landing area features 4 resting wires precisely calibrated to safely stop aircraft traveling at speeds exceeding 150 knots below deck. An intricate network of machinery spaces, control rooms, and support facilities power these operations, ensuring seamless coordination between air and deck crews. Modern carriers integrate advanced systems throughout the rear section. The FROW lens optical landing system provides crucial visual guidance for approaching aircraft. Digital wind measurement systems continuously monitor conditions across the landing area, feeding real-time data to flight control. The ship relative GPS or senior GPS delivers precise positioning information to approaching aircraft, enhancing safety during critical landing phases. The landing area itself spans approximately 700 feet by 120 feet, utilizing special non-skid surfaces that ensure safe operations even in adverse weather conditions. Massive jet blast deflectors rise hydraulically from the deck, protecting personnel and equipment from engine exhaust during recovery operations. These systems work in concert with sophisticated lighting arrays that guide pilots during both day and night operations. Beneath the flight deck, the hangar bay extends through the rear section. This vital space houses maintenance facilities, aircraft elevators, and storage areas for essential equipment. Advanced firefighting systems and damage control stations line the hangar walls, ready to respond to any emergency. The hangar's design allows for efficient aircraft movement and maintenance while maintaining the ship's structural integrity. The stern area includes specialized stations for underway replenishment, allowing carriers to receive fuel, ammunition, and supplies while maintaining flight operations. These stations incorporate sophisticated tensioning systems to maintain safe distances between vessels during transfers, ensuring continuous operational capability even during resupply missions. Primary flight control, often called PRLY, sits high above the landing area, providing commanding views of all flight deck operations. From this vantage point, the air boss and landing signal officers coordinate all aircraft movements. Advanced radar systems and communication arrays mounted nearby maintain constant contact with aircraft and support vessels, creating an integrated command and control network. The rear section design accounts for extreme forces generated during aircraft recovery operations. The arresting gear system absorbs enormous energy equivalent to stopping a 45,000 pounds aircraft from 150 miles per hour to zero in less than 350 feet. Massive hydraulic systems below deck control this process, protecting both aircraft and ship while maintaining operational tempo. Recent deployments demonstrate the effectiveness of these systems. USS Abraham Lincoln and USS Dwight D. Eisenhower conducted simultaneous flight operations in the Mediterranean Sea, showcasing the rear section's capabilities and coordinating multiple aircraft movements. Their success relies on the precise integration of all these components working in harmony, supported by crews trained to exacting standards. This complex arrangement of systems and spaces requires constant maintenance and monitoring. Engineering teams track performance metrics through sophisticated diagnostic systems, adjusting settings based on aircraft types, weather conditions, and operational requirements. Each landing generates valuable data used to optimize system performance and predict maintenance needs, ensuring Maximum readiness for sustained operations. With the layout and systems of the rear section in mind, let's explore how they all come together during actual flight operations. The rear section's primary function centers on aircraft recovery operations, demanding precise coordination between multiple teams and systems. Landing signal officers guide incoming aircraft through the critical final approach, monitoring speed, altitude, and alignment. Their guidance proves essential during the challenging weather conditions or night operations, where split-second decisions can mean the difference between a successful landing and a missed approach. Advanced optical landing systems provide pilots with crucial visual references. The improved FREL-LAN's optical landing system projects precise glide slope information, appearing as a row of amber lights visible up to 3 miles away from the carrier. The arresting gear system operates through a sophisticated sequence of events. When an aircraft tail hook engages one of the 4 wires, hydraulic engines below deck control the deceleration process. These engines adjust their resistance based on the aircraft's weight and speed, ensuring consistent stopping distance regardless of landing conditions. Each wire connects to independent hydraulic systems, providing redundancy and continuous operational capability. Current carrier operations demonstrate these systems' capabilities daily. Recent exercises in the Indo-Pacific region saw the USS Abraham Lincoln conducting more than 100 aircraft recoveries within a 24-hour period. Each recovery requires split-second timing and flawless coordination between deck crews and control systems, with teams working in synchronized precision to maintain operational tempo. Modern carriers utilize integrated technology systems to enhance rear section operations. The ship's relative GPS provides precise position data for approaching aircraft, while digital wind measurement systems continuously monitor conditions across the landing area. This real-time information allows for immediate adjustments to landing parameters, ensuring safe operations even as conditions change. The rear section houses emergency recovery systems, including barriers that can deploy rapidly if standard arresting gears fail. Multiple firefighting stations stand ready, equipped with specialized foam systems designed specifically for aviation fires. These emergency systems undergo regular testing and maintenance to ensure immediate response capability when needed. Recovery operations involve complex communication networks linking multiple teams. The landing signal officers maintain constant contact with approaching aircraft while coordinating with deck crews and flight control. Advanced radio systems operate on multiple frequencies, providing redundancy for mission-critical communications. Visual signaling systems serve as a backup, ensuring uninterrupted coordination even if electronic systems fail. The rear section's design facilitates rapid aircraft movement and recovery. Once stopped, aircraft are quickly disconnected from the arresting wire and directed to designated spots on the deck. This efficient flow prevents congestion and maintains continuous landing operations, allowing carriers to recover aircraft at intervals as short as 45 seconds during surge operations. Below, engineering teams monitor sophisticated diagnostic systems tracking each landing's performance. Data collected includes wire engagement, speed, stopping distances, and equipment stress levels. This information helps to optimize system settings and predict maintenance requirements, ensuring maximum system reliability during extended operations. Recent multinational exercises highlighted these capabilities during operations with Italian naval forces. U.S. carriers demonstrated their ability to recover both American and Allied aircraft seamlessly. This interoperability stems from standardized procedures and adaptable recovery systems, showcasing the versatility of modern carrier operations. Here's a quick question for our viewers: how do you think weather conditions affect the coordination between flight deck crews during aircraft recovery operations? Share your thoughts in the comments below. The rear section's efficiency depends heavily on the integration of these various systems and personnel. Modern carriers can adjust recovery parameters quickly to accommodate different aircraft types, from heavy transport planes to agile fighters. This adaptability, combined with advanced technology and highly trained crews, ensures consistent Performance across a wide range of operational scenarios. Of course, none of these intricate operations would be possible without the highly skilled crews and technical systems supporting them. Specialized crews in distinctive color uniforms operate throughout the carrier's rear section, each performing crucial roles in aircraft recovery operations. Yellow shirt aircraft directors orchestrate precise aircraft movements on the landing area using standardized hand signals and illuminated wands. During night operations to guide pilots with exacting precision, the landing signal officers wearing distinctive white jerseys operate from a specialized platform extending from the port side of the ship. These experienced aviators provide critical guidance during the final approach phase, maintaining verbal communication with pilots while monitoring aircraft parameters. Their expertise becomes particularly vital during adverse weather conditions when visual references become limited. Green shirt maintenance personnel manage the complex technical systems supporting recovery operations. Their responsibilities include maintaining the arresting gear machinery, ensuring proper wire tension, and conducting immediate repairs when needed. These technical specialists work in conjunction with the purple shirt fuel handlers to manage the intricate process of refueling aircraft immediately after recovery. The rear sections engineering spaces house dedicated teams monitoring the resting gears. Sophisticated hydraulic systems, these specialists track performance metrics through digital interfaces, adjusting system parameters based on real-time data. Their expertise ensures proper energy absorption during aircraft recovery, preventing equipment damage while maintaining operational tempo. Red shared ordnance personnel manage weapon systems and emergency equipment in the rear section. Their responsibilities include securing aircraft weapons immediately after landing and maintaining firefighting systems. This team coordinates closely with crash and salvage crews, ensuring immediate response capability for any contingency. Modern aircraft carrier operations require seamless integration between these various teams. Recent deployments of the USS George Washington demonstrate this coordination, with crews processing multiple aircraft types during high-tempo operations. The ship's ability to conduct sustained operations stems from these teams' precise execution of their assigned tasks. The technical systems supporting rear operations incorporate multiple redundancies. Advanced radar and communication systems mounted in the rear section maintain contact with aircraft within a 5 nautical mile radius. These systems integrate with the carrier's Combat Information Center, providing comprehensive situational awareness during flight operations. Modern encryption protocols ensure secure communications even in contested environments. The rear section's design incorporates sophisticated environmental management systems support equipment storage areas near the rear section house essential maintenance tools and spare parts. Mobile crane systems facilitate rapid component replacement when needed, while dedicated workshops enable on-site repairs of idle equipment. This self-sufficiency proves essential during extended deployments away from shore facilities. Recent operations in the Mediterranean Sea highlighted these capabilities when the USS Dwight D. Eisenhower conducted concurrent flight operations with multiple partner nations. The ship's technical systems and crew coordination allowed for seamless integration with allied forces, demonstrating the versatility of modern carrier operations. Continuous training programs and ensure crew proficiency in all aspects of rear section operations. Teams regularly conduct emergency response drills, practice equipment maintenance procedures, and refine coordination techniques. This training maintains operational readiness while developing the expertise needed for complex recovery operations. The integration of these human and technical elements creates a highly efficient operational environment. Each team's specialized knowledge combines with advanced systems to enable sustained flight operations under varying conditions. This capability remains essential for maintaining a carrier strike group's effectiveness during extended deployments. Now, while efficiency is crucial, safety remains the top priority. Next, we'll examine the robust emergency protocols and safety measures in place throughout the rear section. Safety systems in the carrier's rear section represent layers of protection designed for immediate response to any emergency scenario. The flight tech incorporates embedded firefighting stations every 50 feet, each equipped with specialized acoustic film-forming foam or aft systems capable of smothering aviation fuel fires within seconds. These systems can activate automatically when sensors detect excessive heat, providing crucial response time. During critical situations, below deck damage control systems monitor Environmental conditions throughout the rear section. Advanced sensor systems track air quality, temperature variations, and structural integrity. This continuous monitoring enables early detection of potential hazards, allowing preventative action before situations become critical. Dedicated damage control teams remain on standby, ready to respond to flooding, fires, or other emergencies. Safety protocols extend to personnel protective systems throughout the rear section. Integrated respiratory protection systems provide immediate access to clean air during smoke or chemical hazards. Personal protective equipment stations, strategically located near work areas, ensure crew members can quickly don appropriate gear when responding to emergencies. The rear section's design includes multiple escape routes and emergency egress points. Illuminated pathways guide personnel to safety during low visibility conditions, while strategically placed emergency equipment stations provide access to essential rescue tools. These features underwent extensive testing during recent deployment exercises, validating their effectiveness in various emergency scenarios. Communication systems play a crucial role in emergency response coordination. Dedicated emergency frequencies ensure clear communications between response teams, while visual warning systems alert deck personnel to developing situations. These systems integrate with the carrier's general announcing system, enabling rapid dissemination of emergency instructions throughout the ship. These improvements will maintain operational security while increasing information flow during critical moments. The development of unmanned combat aerial vehicles introduces new requirements for rear section operations. Modified recovery systems will accommodate both manned and unmanned aircraft, while enhanced data links will manage autonomous landing operations. These capabilities will expand carrier strike group effectiveness while reducing risks to personnel. Modern sensor integration will create unprecedented situational awareness in the rear section. Advanced radar systems combined with optical and infrared sensors will provide comprehensive monitoring of approach paths and deck conditions. This sensor fusion will enhance safety while enabling more efficient recovery operations in adverse conditions. Future crew training programs will incorporate virtual reality systems, allowing personnel to practice emergency procedures and complex operations in realistic simulations. These training tools will reduce risks while ensuring crews maintain proficiency in all aspects of rear section operations. The integration of artificial intelligence will provide personalized training scenarios based on individual performance metrics. Here's our final question for viewers: what role do you think artificial intelligence will play in future aircraft carrier landing operations? Share your predictions in the comments section below. The rear section of modern aircraft carriers represents an extraordinary achievement in naval engineering, combining advanced technology with skilled personnel to enable continuous flight operations. As these systems evolve, they will incorporate new capabilities while building upon proven operational principles. These developments ensure U.S. aircraft carriers remain at the forefront of maritime operations, ready to meet the future challenges while maintaining their crucial role in naval aviation. If you enjoy this detailed look at aircraft carrier operations and learn something new, please hit the like button and subscribe to our channel for more fascinating content about naval technology and operations. We appreciate your support and look forward to bringing you more in-depth coverage of maritime innovations. Don't forget to hit the notification bell to stay updated on our latest videos.